So good afternoon, friends. It's a pleasure to come to ICTS and give a talk here. I thank the organizers for giving me this opportunity. I'm not used to giving 10 minutes talks, but I'll try my best to tell you exactly what I did on this rather celebrated model in the area of quantum computation. I'm not from the area of quantum computation, but for me, Toric code model is a cute little model of spins, and let us see what I have done here. Okay, this is the paper. If you want, you can see the details. Toric code model. It's basically a square lattice with periodic boundary conditions. And what you have sitting on the bonds are these qubits. You can call them quantum spin halves. They happen to interact, or they are given to interact by 4 qubit interactions, not the usual pairwise interactions. And this model was first time sort of proposed by Kitaev, as I said, in the context of fault-tolerant quantum computation. The interactions are of 2 types, the ones on vertices, these crosses you can see, and the faces of the squares, or the plackets. And you can see on the crosses, these are sigma x matrices, the Pauli sigma x component of the Pauli matrix, Pauli operators, spin half operators interacting. And Z denotes the ZZ interactions. One very interesting and simplifying feature of this model is that all these 4 qubit interactions mutually commute, and hence they are conserved quantities. And in fact, you can see there are 2n, 1 into n, total. So the number of conserved quantities are actually same as the number of qubits in the problem. They also have a natural constraint that if you multiply all these x's together, they give you identities. So there is one constraint, and so on, which leads effectively to 4-fold degeneracy of each eigenmanifold. And that is what makes it a topologically interesting problem. And you could imagine, let us say, the ground state manifold, which has 4-fold degeneracy, being equivalent to 2 physical qubits. So a physical qubit is not the constituent qubit, but this 4 sort of, so these 2 qubits are the 4 degenerate states of the problem. And then, of course, Kitaev also wrote down a somewhat simplistically the ground state wave function for this model. And there has been a lot of interest in this. As I said, people in that community are greatly inspired by these constructions and want to realize them experimentally. In fact, so far the practical realizations have been mostly on planar graphs, on the planar codes. Somehow for experimentalists, it's not clear how to sort of invoke periodicities, although there are recent attempts at realizing it on torus, which is the original proposition of Kitaev, the Toric code model, that is the name. So the model Toric code is the model on torus, Toric. And in spite of all these very interesting developments and the conceptual basis that this subject has seen over several decades, in fact, in my understanding and in everybody's understanding, the implementation of these states or realization of these states on torus remains rather ambiguous, that how actually you would think about generating such quantum states on a torus in real. And that was one of the motivations that I actually got into this problem. Although I must say that I knew about this model for a long time, and this interesting feature that it has all these commuting 4 qubit interactions made me immediately realize that this is essentially a problem of independent qubits, although it is far from looking like independent qubits. And the early insights I had nearly 2 decades ago, or 1.5 decades ago, but only when I realized that people are still struggling with it. So I thought, okay, let me sort of get into this and at least put my perspective on this problem. So what I managed to do are the following 3 things. There are other related things, but these are the 3 key lines you can take home if I don't finish the talk in time. First is, as I said, I had this realization that essentially this model looks like a bunch of independent qubits. So you have to figure out what those qubits are. So this is what I did. I managed to, as I say, unfold the Toric code model into independent emergent qubits. The keyword emergent here is to distinguish these emergent qubits from the constituent interacting qubits. So these are some effective many-body variables which actually behave like qubits and describe the entire Toric code model, but they, in that perspective, the Toric code model is just a bunch of independent emergent qubits. So I basically unfold the problem. Yeah. Where here? This one or which one?
Yeah, the last slide.
No, this is the product. So this is one simple choice of a ground state where you take product of qubits, but then multiply it by these projectors. And these projectors are these non-trivial interactions. So it's not a simple qubit. So the ground state is not a independent qubit problem in the original basis. Okay. It's a highly entangled problem, in fact. So this wave function is not to be, not at all to be thought of as a product state. This is far from product state. So once I could sort of invent the exact procedure by which I could unfold these qubits into independent ones, I could do the other part, which is to construct the exact Toric code eigenstates. So which goes much beyond the standard protocols that are usually seen in the literature, starting right from the days of first proposition by Kitaev. And once I have that, I could even try to sort of see if I can help people who are actually trying to realize them on quantum processors, whether they are based on superconducting qubits or on some trapped atom sort of devices. There are different kinds of candidates for practically implementing it, but that is not my goal. So my point is, can I unambiguously figure out a protocol, a precise circuit, which tells me how to realize these states on a torus? So first point, unfolding the Toric code. I'll quickly take you through a, just quickly expose you to how I unfold it. So, so you think of these qubits as like, some dots tied through these strings. And I literally want to sort of untie these strings, which mathematically speaking, I want to figure out the right transformation which does it for me. So I do it in stages. So for example, I could figure out a way to untangle these guys. Then I do the same thing for the next column, the next column, the next column, the next column. What remains at the end of this exercise, I'm sorry, I'll show you the matrix, the actual operator later, but just for people with diverse background, it's easy to sort of get the masses right rather than the technical details. Is it already 10 minutes? I thought it was 3 minutes. Sorry. Okay. And then you have some residuals terms, which you can also get rid of. And the end result is just the independent qubits, plus 2 missing qubits because of the torus, and 2 accumulation terms, which are practically not doing anything. And what this exercise shows that Toric code model is actually exactly equivalent to 2 independent Ising chains, no more, no less. So although this model doesn't look like 2 independent Ising chains, but in this transformed version, it is exactly equivalent to having 2 independent Ising chains. And then you can construct exact eigenstate. Sorry, just allow me, I'll just quickly finish it, not too many slides. So this is the exact closed form expression, which basically describes the, this is not for one state, this is for any Toric code eigenstate, which are labeled by the emergent qubit quantum numbers, the x's and z's. The missing qubits, which are in physical space, you could call them logical qubits. And it is probably the most complete expression written for Toric code eigenstates. And importantly, the excited states do not require to be described any differently from the ground state, which means this closed form expression applies to all states. So this whole business of having a ground state manifold and creating fluxes or creating particles, at least for this exercise, it's not particularly exciting. And then the third important part is exact quantum circuits. This is an important realization that the transformation which I actually construct can be exactly reduced into C0 quantum gates. So this is the mathematical typical term that appears in my transformations, but it basically means a sequence of C0 quantum gates. And so this is, for example, in a simple way, these are the 4 steps that unfolded for me the Toric code, the 4 parts of the unitary transformation. And you could construct, as I said, these mathematical equations can precisely be translated into a circuit of C0 gates. The number of C0 gates required is extensive in number of qubits, but the circuit depth can be sub-extensive for ground state manifold. However, in general, because of periodicity, the circuit depth will be extensive. On planar codes, for example, it is always found to be sublinear, but on torus, in general, if you want to construct a toric code eigenstate, it may require you to have extensive circuit depths. But at least for some low energy states, you can still do it. And you can, in fact, go much beyond what people anticipated, or I mean, people did not even anticipate. You could actually generate any linear superposition in a given manifold. So you can really play with these 4 states in each manifold and generate whatever you want to do. So summarizing it, toric code model rigorously transformed into independent qubits, complete set of eigenstates constructed, and exact quantum circuits devised for generating any toric code eigenstate. Thank you very much. And thank you for giving me these few extra minutes. Thank you.
One quick questions.
There is one, yes.
So you get this two Ising model. What are the Ising model? Transverse field kind of
Sorry,
thing?
say it again.
So you get, after those unfolding, you
Yes,
get
I say that this is equivalent to 2 independent Ising chains, yes.
what kind of Ising? Transverse field or classical?
No, just classical Ising chains.
Classical Ising chain.
Yes.
Oh, okay.
So this actually, I think of toric code model as a classical model in disguise of quantum, Okay. So it's a very, in fact, this is like 2 copies of the famous, Wagner's Ising lattice gauge model. So,
but
anyway.
already toric code can be.
So let me just to answer you a little more understandably. So there are these 2 kinds of operators, X's and Z's, correct?
Yeah.
Right. So there are 2 terms here. The X operator sitting on the crosses, the Z operator sitting on the plackets. And I'm saying the bunch of X's like, behave like one Ising chain in my transformed version, and the Z's behave like another Ising. Although it is not apparent from here, but I'm saying mathematically they are equivalent. But it is not obvious until you do the process I did.
Okay. Thanks.
Yes.
Okay. Okay, then let's thank the speaker again.